Welcome to the glass plate. In this exercise we're going to make hot water as we would like to have a cup of tea. Thus we take water from our tap, put it into an electric heater, a cooker. Say we start with water of 15 degrees. And then here we can switch on a heater which has an electric power and heating power of 2200 watt. The volume of water that we're going to boil is half a liter. And we would like to know how long does it take before this water is at boiling temperature, 100 degrees. To do so, we need to think in terms of energy. This system needs to be brought at a higher temperature, meaning a higher internal energy. And thus we're going to set up an energy balance. Obviously, it's an unsteady balance. The temperature of the water will increase, and it cannot be a steady state situation. Which energies do we take into consideration? We have, on the one hand, heating up, which is internal energy, temperature rises. We could think about potential energy, we could think about kinetic energy, but the latter two are irrelevant here. All the energy that we put in, by and large, goes into heating up the water. And we're going to make an analysis with a few simplifications. There is no heat loss to the surroundings, which in practice will take place as this heats up. Some of the heat is lost to your kitchen. We're going to ignore that. Second is, we're going to ignore that here at the top, the layer, you will start making vapor, and that vapor, one, will escape and carry out energy, and two, to make vapor, you need to change from a liquid to a gas, and that consumes energy. Also ignored. Finally, we're going to assume that the specific heat, C, is a constant during heating up, which is not true, but the deviation is small, so that is not too big an assumption. Okay, if we have this, we can set up our energy balance. Du dt, because we're only considering internal energy, no kinetic, no potential, and so on, equals what comes in minus what comes out plus what you produce. Well, you don't produce anything. There's no energy production inside. There's nothing flowing out. I've forbidden that. The inflow, that is what the heater gives us. That's what the heating element is for. So Q dot in joules per second is the inflowing energy. Or, if we stick to the terminology that we usually use, there's an inflow of heat, phi sub Q. And that is the same, there's this amount of heat coming in. Thus, I can simplify this, and I can simplify further by looking at the internal energy. A small change in temperature, so a small change, will give us a change in internal energy. And it depends on the mass of the system and the specific heat. If we combine these two, I get my equation for the temperature change. mCp dt over time equals the heat put in. This can be brought to the other side, so I can turn this into a straightforward differential equation. I'm going to write that here. That tells us how the temperature is changing over time. Phi q over m and over specific heat. This is a relatively simple differential equation. Everything on the right hand side is constant, so I can easily integrate this, giving me that T as a function of time equals flow in over mCp times time plus, should not forget that, some integration constant, which I can find from the initial condition that at T equals 0, I have that the temperature is T naught. Substitute T equals 0, then you get a 0 here, T naught on this side, so this one equals T0. If you look up a specific heat of water, which is about 4,200 joule per kilogram Kelvin, and if you back out that this is half a kilogram, because we had half a liter, Now you can compute from this equation, knowing that this is 15 degrees Celsius, how long it takes before T temperature equals 100 degrees. Your water is about to boil. That will take 81 seconds. Obviously in practice it will take longer. These two cannot be neglected. You will lose heat. The better your cooker is insulated, the less this will be. But you will generate vapor if it starts boiling. And generating vapor consumes a lot of energy. So the real boiling takes a little bit longer of time. But reaching 100 degrees is on this ballpark number. 1.5 minutes, 2 minutes for this cooker.